Today I'm going to show you how to create a circular array and unlock the power to spawn objects along any curve the right way. We'll start with a classic method using the array and curve modifiers, but then I'll take you through a simple yet powerful geometry node setup that's super customizable and absolutely worth memorizing. Trust me, you'll want this trick in your Blender toolbox. Start by selecting your object and adding an array modifier. Then create a curve object, typically a circle if you're aiming for a standard radial array. Align the curve with your object and pair them together so they stay linked when transforming. Simple and effective. Anyway, we know that the real deal with automation in Blender is to use geometry nodes, so there are some common and very useful setups that you should know and keep in mind. One of them is a circular array using points on a curve. It gives you far more control, flexibility, and reusability than a classic modifier stack. Once you understand the logic behind it, you can easily adapt it to different shapes, spacing, and even animations. So let's break it down step by step and build something you can actually reuse in your projects. So start with any new object. This will just be a sandbox for the setup, since it'll be replaced by the geometry node's output anyway. Add a geometry node's modifier, then drag the object you want to spawn into the node editor. Do the same for the curve object. Next, connect both object info nodes to the group input node. This will expose them in the modifier panel, making it easy to swap in different objects and curves later on. This small step makes your setup much more flexible and reusable, especially when working across multiple assets or scenes. Then, connect the curves object info node to a resample curve node. Expose the count input of the resample node by connecting it to the group input. This will allow you to control the resolution of the curve directly from a modifier panel. Now it's time to bring in the instance on points node. Plug the output of the resample curve into the points input and connect your object from the object info node to the instance input. Finally, link the output of instance on points to the group output. That's it. You should now see your object duplicated along the curve. I know there's one important thing missing in this setup. Right now, the instance objects are being distributed along the curve, but they're not rotating to follow the direction of the curve. That means they all face the same way, which breaks the illusion, especially on circular or complex curves. So, let's jump back into the geometry node's editor and fix that by adding orientation to the instances. We'll start by adding a curve tangent node and a normal node. These will give us the orientation data we need. Next, add two align Euler to vector nodes. Connect the output of the curve tangent node to the vector input of the first align Euler to vector node. Do the same with the normal node and the second align Euler to vector node. Now, take the rotation output from the first align node and plug it into the rotation input of the second one. Then, connect the final rotation output from the second align node into the rotation input of the instance on points node. At this point, your instances should be aligned along the curve direction. Adjust the axis settings on each align Euler to vector node depending on how your object is oriented. And that's it. You're good to go. This is the basic setup, and it's definitely worth memorizing. It's incredibly useful for spawning objects along curves, not just for circular arrays. But now, let's take it a step further and make the setup more flexible and generic. First, I'll add a switch node. This will let me choose whether or not the instances should follow the curve's orientation. It's a simple way to toggle rotation on or off, depending on the use case. Helpful if you want flat or static-facing objects. Next, I want to make sure the system also works when the curve is actually a mesh. For example, if you're using a mesh object made up of segments. If the input object is a mesh, I'll convert it into a curve using the mesh to curve node. That way, the setup can handle both native curves and mesh-based paths, automatically adapting as needed. With this, the system becomes much more robust and reusable across different scenarios, perfect for modular setups or procedural level design. The next three nodes are key to achieving a clean and smooth result. First, we add the mesh to curve node. As expected, this converts any mesh input into a curve. Next, I use a set spline type node to convert the curve to a Bezier type. This gives us more control over the shape and smoothness of the curve. Finally, I add a set handle type node. I enable both the left and right toggles and set the handle type to auto. This ensures that the curve transitions smoothly between points with natural, rounded bends, perfect for clean, visually pleasing distributions. These nodes help standardize the curve behavior, especially when working with converted mesh paths. And they make sure your instances flow nicely along the entire curve. Now that the mesh gets properly converted to a curve, I can feed it back into the resample curve node, just like we did earlier with native curves. To make the setup fully dynamic, I'll add a switch node that lets me choose whether the input path is a mesh or a curve. This way, the system can handle both types cleanly, and you won't need to manually adjust the node tree depending on the object type. With this switch in place, you'll be able to plug in either a mesh path or a curve object, and have everything work seamlessly, all while maintaining the same instancing and rotation logic. Last but not least, I want to add the ability to offset the instances along the curve. This feature is especially useful when you're spawning different objects on the same path and want to avoid overlaps or create interesting spacing variations. To do this, I'll add a normal node and connect it to a vector scale node, which essentially performs uniform vector multiplication. Then, I'll use a set position node and apply this offset to the curve geometry. This allows you to shift the entire curve slightly before the instances are placed, giving you fine control over each object's position along the path.